conceptual design of repair. So no details yet be determined. And how, the question is, how do you get the concept? I showed you last week, it is from structure repair manual. Last week I've shown you for A320 SRM, there is already example number 1 to 11 as general guide. So that's how this concept been developed based on the structure repair manual of the aircraft. So what is next? What is next to do the detail? To do the detail, you don't use isometric view, we just use a simple 2D sketch. So we have pillar, we have doubler. So if this is considered flush repair, so the doubler is okay. The doubler is hidden inside the aircraft skin, so we can see it will be a dotted line. You can see the thing. So be careful on the drawing here, because when you do the drawing, people forget about this hidden line. You go back to your technical drawing. I don't expect you to do the technical drawing here, but what I'm trying to say is go back and try to understand again your technical drawing. So that is a filler. Okay. Then there will be a aircraft skin. So this is a section of aircraft skin. And you have damage, you cut off, you put a doubler. So this is the rivets. So this is rivets. Okay. So those rivet. Sorry about the symbol. It's different sizes, actually same size. Rivet all over the place. So we have to do the labeling for this sketch. So we have to label. So this is the okay. This we call it leader. We label. You can see here for population skin, alum, alloy 2024 T3 S 1.6. So that is label. You must have proper label. Your repair design. So this is a label. This is filler. Aluminum alloy 2024 T3 1.4 mm. That's original. Have to go back to the original size. And here we label rivets. I would say rivets. So rivets. Okay. MS 20470, and we can say diameter 4 mm. We find it from the table, depending on the thickness of the original material. Then you have to label, another label is edge distance. The distance between here, rivets and the skin, we call this as edge distance. So here is edge, this ED, edge distance. Edge dimension between rivet and the edge. And typically, edge distance is 2D. Means that 2 times 2 times diameter of rivet. Now see, we have chose 4 mm. So 2 times 4, you have 8 mm. From the doubler edge to the fastener hole. And another label is rivet spacing. Rivet spacing is the distance between rivets. Here is rivet spacing, or also consider pitch, which is 4 to 6. D means 4 to 6 times diameter. In this case, if we choose 4 times 4, 16 millimeter. If we choose 6 times 4, and you have 24 diameter, 24 millimeter. So this is typical how you do the proper sketching for the repair, and this is important. You have to get all the information, because this information will go to the mechanic. Mechanic will do the selection of material and will embody the repair. So this is what we do. And the next thing is we have to check whether what we do here are having the strength required. So this is first stage concept. Second stage is detailing the design, the repair. The third stage will be testing the strength. You check the shear stress, you check the tension stress, you check the buckling, crippling of the repair plate, plus shear the fasteners, bearing on the holes of the fasteners or the rivets, and also the network tension, tension failure across the plate, and tension to shear out from hole to the edge. It will be calculated after this. So now we go into the third stage is to do the stress calculation. And you also need to do the cross section to show what exactly to get the information to the mechanics, so for them to be able to be easier for them to embody the repair if we get as much information as we can to them. Questions?
Sorry
Yep.
for questions. For the conceptual design, after we did the conceptual design and as well the detailing, do we need to